Hello friends, this PPT explains about supervised machine learning. My name is Vinod. There are so many applications of machine learning in the real time. Let us see one by one. In this PPT, I explain about the supervised machine learning. What is the difference between the supervised and unsupervised? Let us see first. Before going to all the things, let us see the contents of this PPT. Introduction, types of learning, supervised machine learning, statistical learning algorithms, naive Bayes classifiers, Bayesian networks. What is a machine learning? Machine learning systems automatically learn programs from data. It is a programmed one. This is often a very attractive alternative to manually constructing them, and in the last decade the use of machine learning has spread rapidly throughout computer science and beyond. Machine learning is used in web search, spam filters, recommender systems, ad placement, credit scoring, and many other applications. Machine learning algorithms can figure out how to perform important tasks by generalizing from examples. This is often feasible and cost-effective where manual programming is not. As more data becomes available, more ambitious problems can be tackled. As a result, machine learning is widely used in computer science and other fields. So basically, we understood that machine learning is a programmed one. If you program anything to a system, it does that. How to program and how to make use of that program, it is all depend on the algorithm we used. So this study is called machine learning basically. Types of learning. As explained, there are two types of learning, supervised and unsupervised. Supervised means we know this output. Unsupervised, we do not know the output. Let us discuss in detail. Every instance in any dataset used by machine learning algorithms is represented using the same set of features. It may be continuous, categorical, or binary. If instances are given with known labels, the corresponding correct outputs, then the learning is called supervised. In contrast to unsupervised learning, where instances are unlabeled. In this PPT, we only discuss about supervised machine learning. Numerous machine learning applications involve tasks that can be set up as supervised. The goal of supervised learning is to build a concise model of the distribution of class labels in terms of predictor features. The resulting classifier is then used to assign class labels to the testing instances where the values of the predictor features are known, but the value of the class label is unknown. Statistical approaches. Now, statistical learning algorithms. Before going to this, what we have in the machine learning techniques? There are so many techniques. Basically, particularly in the supervised machine learning, we have so many techniques to implement the algorithms. Basically, there are instance based learning, statistical learning, and there are new type of machine learning, that is super vector machine, perceptron based learning. These are all types of techniques we use to implement the algorithms, or these are called algorithms, which are used for machine learning, supervised machine learning particularly. In this, we are restricted to learn the statistical learning algorithms. My PPT is restricted to statistical learning algorithms only. Statistical approaches are characterized by having an explicit underlying probability model which provides a probability that an instance belongs to in each class rather than simply a classification. Bayesian networks are the most well-known representative of statistical learning algorithms. Naive Bayes classifiers. Naive Bayesian networks are very simple Bayesian networks which are composed of directed acyclic graphs with only one parent representing the unobserved node and several children corresponding to observed nodes, with a strong assumption of independence among child nodes in the context of their parent. Thus the independence model naive Bayes is based on estimating. This is a probability, this is a conditional probability. It is represented by using the mathematical notations called the conditional probability. R is equal to P of I with assumption X, that is a notation, it's dividend. Comparing these two probabilities, the larger probability indicates that the class label value that is more likely to be the actual label. If R is greater than 1, predict I, else predict J. Since the Bayes classification algorithm uses a product operation to compute the probabilities P of x, I, it is especially prone to being unduly impacted by probabilities of 0. Semi-naive Bayesian classifier is another important attempt to avoid the independence assumption. So it is represented by the conditional probability, and if is R greater than 1, predict I, else predict J. This is an algorithm. Bayesian networks. A Bayesian network is a graphical model for probability relationships among a set of variables. The Bayesian network structure S is a directed acyclic graph, DAG, we called it as DAG, directed acyclic graph, and the nodes in S are in one-to-one correspondence with the futures X. Typically, the task of learning a Bayesian network can be divided into two subtasks. Initially, the learning of the DAG structure of the network, and then the determination of its parameters. This is the structure of a Bayes network. This is a DAG. By seeing the figure, we can clearly understand. Bayes network is all based on the probability only. So here P of x1 is 0.95, x2 P of x2 is 0.95 again. So probability which is less than 1, 0 and 1 it is between. X3 and x4 is also mentioned probabilities. By seeing that, what we are concluding, the arcs represent casual influences among the futures, while the lack of possible arcs in S encodes conditional independences. Moreover, a future node is conditionally independent from its non-descendants given its parents. x1 is conditionally independent from x2 given x3 if P of x1 assumption of x2, x3, P of x1 assumption of x3 for all possible values of x1, x2, x3. So this is the conclusion we have given here. Probabilistic parameters are encoded into a set of tables, one for each variable. So this one later is mentioned in the pseudocode in the form of local conditional distributions of a variable given its parents. The most interesting feature of BNs compared to decision trees or neural networks is most certainly the possibility of taking into account rare information about a given problem in terms of structural relationships among its futures. So this is the statistical learning algorithm in which we have discussed Bayesian network, which is the most effective algorithm in the statistical learning algorithm. Thank you.